Hello, students. Today we are going to see a new chapter which is known as scoping. So, in this chapter, we are going to understand what is scoping, how we are going to implement LEGB rules. Okay, so this LEGB means we'll be seeing in detail in the upcoming session. So, and then next, what we are going to see is understanding the modules. Okay, so what is meant by module and characteristics of module, everything can be seen, and understanding and implementing access control of a programming language. Okay, so these are all the things that we are going to see in this chapter. So let's get into the chapter. So first is scope. So scope refers to the visibility of a variable, parameter, and function in one part of the program to another part of the program, same program. So in one part of, so there are so many values or so many datas can be accessed in one program. Okay, so the visibility or availability or accessibility of that particular variable or data or function or object in which part of the program is known as accessibility. Okay, some of the variables can only be accessed in certain part of the program, so you cannot able to access that particular variable outside that particular part of the program. Okay, so this concept, okay, so this type of accessibility issue or accessibility restriction is known as scope. Okay, so here you can see that um, you in other words, which part of the program can see or use it. Okay, normally every variable defined in the program has a global scope. Once defined, each part of your program can access that variable, but it is good practice to limit the variable scope to single definition. This way, changes inside that function cannot affect the variable on the other side of the function. It is an unexpected way. So here you can see that when you define when you give a variable or object a global scope. Okay, global scope means whatever program in which throughout the program you can access that variable and change it. So uh, that is global scope. Okay, so if you give this variable as a global scope, any uh, part of the program can access this variable and can change it. So this is a disadvantages. So it's a good practice to use the variable as a local scope, which means that you can restrict the accessibility of that variable or object. Okay, uh, so next is variable scope. So the scope we have understood. So what is scope? The visibility of variable or object from one part of the program to another part of the program in the same program is known as visibility. So sorry, scoping. So variable. So only this variable can be done. Okay. So to understand the scope of variable in a programming language, it is important to learn about what variables really are. Essentially, there are address to an object in a memory. Okay, so what is variable? Okay, before getting into the scope of variable, we must understand what is meant by variable. Okay, so variable is a memory location. Mm, which consists of address. Say for example, it will be like 6-digit numbers. Okay, you cannot able to remember the address of the variable memory location. So so that's why this programming language has given this variable concept called variable. So this variable will be given some name. Okay, will be given some name. So that name can be defined by the user itself. Okay, so that the user can define their own names for this memory location. With that name they can refer the memory location either by accessing the value or modifying the value. Okay, so this is variable. So now get into this. uh, yes, you can assign values to the variable just by using this symbol which is known as equal to. So this equal to symbol will get the value and store it in that respective memory location. Okay, so next thing is namespace. There is a concept called namespace or uh, containers for mapping names of variables to objects. Okay, so namespace is a concept. So that is a kind of work or number of task. Okay, so namespace is a task that is it will collect all the variables in a program, and it will have a ledger like thing. Okay, so this variable is known as a variable a, and it can hold this kind of value, and it is only accessible in this part of the program. So this kind of ledger is maintained in this namespace, so to avoid confusion. Okay, so the the person who is creating or the compiler will not get confused, since it will have this ledger. So you may come across certain type of variables with the same name, okay, in same program. So at that time, this same part of the program but having or holding different values. Okay, so this kind of confusion can be avoided by using this namespace. So namespace is a ledger that holds all the variables that are created in a program, and it changes that variable name to objects. Okay, so that is the thing that is given here. So here they are given one example. So a is equal to 5. So next is b is equal to a. Now the value of a is 5, and now they are changing the value of b to 5. Okay, so indirectly they are giving the value of a to b. Okay, so if you access value b, then it will be value 5, not a. Okay, so this is a way of providing this is a way of providing the values to the variable. Okay, so this is mapping. Here you can see that a equal to 5 and b also equal to 5. So here they have given another one example here. So here you can see that if you change a to be equal to 3, binding programming might expect b is also to be equal to 3, but this is not in case. B is still mapped to be integer value of 5. So the only thing that changes is a, which is now mapped as integer value 3. Okay, so mapping can change the value of a. The scope of variable is a part of the code where it is visible. Okay, So here you can see that it is a bit like confusing. So uh, so a is equal to 5 in the first step. In the next step, you can see that b is equal to a. Now it is by indirectly they are providing b is equal to 5. But in the next step, a is equal to 3. It is changed as a value is changed as 3 here. But they didn't change the value of b. So since they didn't change the value in the next step of variable b, the variable b will have the value same as 5. Okay. So so this is known as scoping of variable. Okay. So scoping of variable, sorry, mapping of variable. And you can see that next thing is this Legb rule. So L means local. Yes, here you can see that L means local, E means enclosed, G means global, uh, B means built-in. Okay, so we'll see one by one. So local means defined inside the function or a class. Okay, so a variable will be declared inside the variable or sorry, inside a function or a class. So that particular variable only can be accessed inside this function or that particular class. Next is enclosed. So this is so we'll see the example one by one. Okay, so this is local. So this is local in local local um, local scope. So disp is a function, disp. Disp is a function that contains two instructions. So a is equal to 7 and print a. Okay. So here you can see that they are calling the disp function outside the function. Okay. So this a is equal to 7 is a local value that can be accessed only inside this disp function. Okay. So this is known as local scope. Okay. Next is enclosed scope. Okay, global scope. So here you can see that a value a is equal to 10 is declared outside all the functions. Okay. So you can access this a is equal to 10 anywhere in the program. So disp is a function that is created, and inside that another a value is created. A is equal to 7. So this is a local function. Now they are printing the value of a, which is equal to 7 here. So now after that they are calling the disp function, and then you can see that they are just printing the value of a. Okay. Now here you can see that the output of this program, okay, when calling in the fifth statement, they are calling the function disp. So the value of the function of disp is assigning a value of a is equal to 7 and printing the value of a. So that's what you can see that the first instruction, the first output 7 is the value that is printed. But after finishing that, you can see that in sixth statement print a is given there. Okay, so when that particular statement is executed, a is equal to 10 is printed. Okay, so this is global scope. Next is enclosed scope. Okay, so here you can see that a function which is inside another function is created. Okay, so that function is uh, accessing the value of outside function. Okay, so this is enclosed function. Okay, so here we'll see that example, you can understand that in a better way. So disp is the function that consists of value a is equal to 10, and inside this disp function they are creating another one, disp1. Disp1 is another function inside a function. Okay, so in that print a, they are accessing the value of a is equal to 10 from inside the uh, nested function. Okay, now they are calling the uh, disp1 function, and they are trying, then in the sixth statement they are coming out of the uh, loop, sorry, they are coming out of the scope here. So print a is uh, accessing the a value 10 here, then, and it is printing it. In the seventh statement they are calling the whole uh, disp function. So here you can see that the first print function is called by the inside function, which is a is equal to 10, and the a second output 10 is printed by using this print statement in the sixth statement. Okay, so this is what it is given here in this statements. Okay, so next is built-in function. So some variables are provided, or in the some values are defined inbuilt by the programming language or the compiler or from the operating system itself. Okay, you didn't create that variable, or you didn't give the value for that particular variable. So but you can access the variable, or you can use the value of that variable. Okay, so this is known as built-in scope. So this built-in scope is uh, illustrated here in this example. So with this we'll finish the class today. We'll see the modules and the characteristics of modules in the next class. Thank you, students.